Alexander. Thank you for this invitation. So my presentation, as Denia already said, will be about the work that has been carried out by the Technical Committee of the European Cool Roofs Council. This is the outline of my presentation. So apart from a very brief introduction, I will speak to you about the standards that are currently used for evaluating cool roofing materials, the efforts that have been made towards creating a European standard for cool roofs, a bit more in detail the ECRC Cool Roof Rating Program, and the future developments that we are now carrying out within the Technical Committee of the ECRC and are related to aging. So, as Denia already explained in detail, cool roofs contribute to mitigating climate change, reduce the urban heat island effect, and of course increase the sustainability of buildings. A lot of organizations support the application of cool roofs. The European Cool Roofs Council has played a very important role in Europe in boosting the market of cool roofs and the technology also. The main aim of the Technical Committee was to formulate a cool roof product rating program, and this has been achieved, this has been launched, and we will speak about that more in detail in the following slides. And the second objective was to include cool materials in European standards. We have done some work towards this direction, and again, I will speak to you more in detail about this in the following slides. So, starting with the cool roof standards, I would like to focus first on the two properties that actually define cool roofing materials. So the first property is the solar reflectance, and the second property is the infrared emittance. Regarding the measurement of solar reflectance, there are several methodologies that are being used using different instrumentation. The first one is the use of a spectrophotometer with an integrating sphere. This gives the total hemispherical reflectance of a small area of the sample, around 0.1 square centimeter. The sample has to be flat and uniform, and the range of the measurement covers 250 nanometers to 2,500 nanometers. Good practice procedures for the spectrophotometric measurements of the optical properties of materials are described in different standards. For example, the ASTM E903 standard that is currently adopted by the European Cool Roof Council as the standard for measurement of the solar reflectance, but also by the US Cool Roof Rating Council, but there are also other standards that describe these good practice procedures, like the EN 410 and an ISO standard. So these standards describe how to measure, let's say, the reflectivity of the material. Then we want to calculate the solar reflectance, and this can be done by weighted averaging and using a standard solar spectrum. The second method that we can use to measure the solar reflectance is the use of a portable solar reflectometer. This is mainly used by the industry. This is it is an easier and quicker measurement that gives the solar reflector of a uniform sample of an area of about 2 square centimeters, and there is a standard related to this device, an ASTM standard. This standard is also acceptable by the ECRC and the CRRC. And the third methodology is the use of a double pyranometer. This is used for in situ measurements. So when you want to measure the solar reflector, let's say, in situ of a roof. So this gives the clear sky global solar reflectance of a horizontal, or let's say near horizontal surface of around 10 square meters. Again, there is an ASTM standard available for this method. Now, for the measurement of the thermal emittance, Usually we use portable devices for that. There is one device that it is mainly used by the industry. It is the Devices and Services Emissometer that measures the infrared emittance in the range of 5 to 800 micrometers, and there is a specific ASTM standard related to that. Some years ago, there was a new instrument introduced by a European company that is also a portable emissometer, measuring the infrared emittance in a more or less similar way, and there is a NEAN standard related with this instrument. You can see here the standard. And the third methodology is the use of an FTIR spectrometer equipped with a golden sphere. This methodology comes mainly from the glass industry, and the standards related with this instrumentation usually refer to glass, as you can see the EN 12898. Another important property that we should mention here is the solar reflectance index. Actually, this index combines the radiative properties, so the solar reflectance, the infrared emittance, but also take into account convective cooling effects in one scheme. So it quantifies how hot the flat surface would get relative to a standard black and a standard white surface. It is a very convenient index as it gives you, let's say, very quickly a measure of how cool a product is. There are several online calculators that can be used, and you can see the references in the bottom of this slide that you can use in order to calculate the SRI once you have the values of solar reflectance and infrared emittance. Now, I would like to talk to you about the efforts that we have carried out within the European Cool Roof Council in order to develop a European standard. So the first step was to conduct an interlaboratory comparison. 12 European labs have participated, and the aim was to provide the ECRC with information regarding its product rating program under development, aiming to compare the different measurement methodologies, mainly the ASTM and European standards that are used for measuring and calculating the solar reflectance and the infrared emittance. The results of this interlaboratory comparison have given us information on the suitability of the various standards in order to be used for a product rating program, and also we have shared our results with a relevant technical committee of SEN that is working towards developing this European standard on solar reflectance and emissivity. Now, a few words about this interlaboratory comparison. What we did is that we chose 17 samples that represent the range of commercially available roofing materials that cover the full range of reflectance and emittance values. You can see the list here. These are the 12 labs that have participated, and you can see here the available instrumentation. So we had spectrophotometers, reflectometers, and the two emissometers, the portable emissometers that I mentioned earlier. And the main findings was that there is a strong correlation between the solar reflectance determined by a spectrophotometer and the reflectometer. So this has given us, let's say, the information that both of these standards and methodologies can be used for the product rating program. What was very interesting is that we found that it is very important to choose a specific solar spectrum for the calculation of the solar emittance. Otherwise, we would probably get some difference in the results which could cause problems in the framework of a product rating program. And regarding the emissivity, we found that there is a strong correlation between the two, let's say, methodologies with the two emissometers for flat roof products. So they can be used both for the product rating program. We have identified, as I told you earlier, a technical committee within SEN that works on the development of a standard for the solar reflectance and the infrared emittance, and we have shared the results of this interlaboratory comparison that we have carried out with the working group of this technical committee. They have approved this recommendation, and they have agreed to, let's say, convert the respective ASTM standards into European standards. There was a delay in this process, which was caused to several legal issues that had to do with this agreement between SEN and ASTM. However, we received the last week's a notification that this working group is reactivated and will actively work on the preparation of a standard on solar reflectivity and thermal emissivity of outer waterproofing layer, referring, of course, to ASTM standards. Now, some more details about the ECRC product rating program. As Denia said, this program is a uniform and credible system that rates and reports the radiative properties of roofing materials, and this was launched in 2015. It gives roofing product manufacturer and sellers the possibility to label their roofing products with radiative property values, and gives code bodies, architects, building owners, specifiers the opportunity to have credible radiative properties data. We are focusing on solar reflectance and infrared emittance, and also we are reporting the solar reflectance index. And these values, of course, are verified through testing by approved testing laboratories and the process of random testing of rated products. And what is important to point out here is that the ECRC does not specify minimum or target values for any radiative property. We just let's say, guarantee that the reported values are correct. This is a list of the standards that have been adopted by the ECRC. So, in the ECRC product rating program, we have the approved and accredited laboratories that test the various products, and of course we have the rated roof products and two different processes for these two categories that I will present to you right away. So in order for a laboratory to participate in the European Cool Roof Council's product rating program, it has to be ISO 17025 accredited for one or more of the ECRC approved measurement methods, and it also has to agree to participate in our quality assurance procedures. We have agreed that in order to, let's say, give incentives to new laboratories to participate in this program that are not yet ISO 17025 accredited, that we can accept for a period of 1 year laboratories that have just initiated the, let's say, ISO accreditation procedure. This is a list of the laboratories and the measurement methods that are currently conducted by the ECRC. You can find this information, of course, on our website. The product rating process is quite simple, so a manufacturer that wants to rate his products, he contacts the ECRC, informs the ECRC Secretariat about this, then he chooses one of the testing laboratories and sends his samples to the laboratory, and once he receives the results, he submits an application to the ECRC. The ECRC checks that all the documentation is correct and that all the processes have been followed correctly, and if the certification board gives the okay, then let's say the product of the manufacturers have the right to enter the ECRC rated products database, and the manufacturer has the right to use the ECRC rated product label. This is the label for rated products. I think that this will be changed in the following months as we have decided to adopt a new logo for the ECRC. This is the rated products database. You can see the information that is available here. So you have the product ID, the brand, the product type, the initial values of solar reflectance and infrared emittance and solar reflectance index, and also some specifications of the products. The rated products have the right to remain in the database for 3 years, subject to the possibility of renewal, of course. All the information regarding product rating are included in the ECRC Product Rating Manual, which is available on the website, and all the information is, of course, available on the website under the Product Rating Program. The first products were rated in February 2016, and you can see here, let's say, a very classification, a very, let's say, simplistic classification of the product. So mainly we have field-applied coatings, but also some single-ply thermoplastic materials and some modified bitumen membranes. And very quickly, I would like to mention to you the quality assurance procedures that we have adopted within the product rating program in order to assure that our processes and the values that we give are credible. The first is an interlaboratory comparison testing for the laboratories that participate in the ECRC product rating program. So this is organized once per year and ensures the consistency and competence of the laboratories by evaluating the test results against other laboratory values. And the second methodology that we use is the random testing of rated roofing products. So we periodically select rated roofing products from the market, and we test them by an accredited testing laboratory, and we compare the results with those that are already on the database. And finally, the future developments. As Denia mentioned in her introductory presentation, aging is a very important aspect that affects the performance of cool roofs. Aging is caused by weathering and soiling. It can alter the radiative properties of roofing materials. Actually, products can suffer significant losses of solar reflectance, especially those with high initial solar reflectance, while products with very low initial solar reflectance tend to become a bit more reflective as they age. What is important is that there are significant differences in the aging of among products of different types and in different climatic conditions. It has been found that for roof products with high initial solar reflectance, aging might yield to a mean absolute loss of about 0.16 after 3 years of natural exposure. And this also applies to European conditions, as testing has showed that the mean absolute loss of solar reflectance of highly reflective materials after 2 years of natural exposure can range from 0.14 to 0.24. So aging significantly affects the performance of cool roofs by increasing the roof surface temperature and by reducing the cooling load savings by an average of 20 to 30%. And it is very critical to rate cool roof products in terms of their aging. How is the aging assessment conducted? One way is natural exposure, and this is, let's say, the current practice of the U.S. Cool Roof Rating Council. It involves exposing the samples to outdoor ambient conditions for a period of 3 years. There are several standards related to this. A second methodology is the artificial weathering that consists of introducing the sample into accelerated degradation in testing chambers. However, in this procedure, the soiling is not taken into account. only weathering is taken into account. And there is a third methodology that has been introduced the last year. It is actually an aging protocol that has been developed by Lawrence Berkeley Lab, and it combines it actually is an accelerated aging method that incorporates features of soiling and weathering and tries to mimic the results of natural exposure of materials. A variant of this protocol has been tested to reproduce the aging conditions in European conditions, actually in Italian urban areas, with promising results. So this is something that the ECRC will also examine. So our decision, taking into account that in order to assess cool roof products' long-term performance, it is necessary to measure the aged product's radiative values, the ECRC is now actively working towards adopting a system for the rating of aged products. It will integrate natural weathering in the ECRC product rating program. We have, as Denia said, identified the locations where we want our products to be exposed, and we have contacts with 2 weathering test sites, and we are confident that we can start, let's say, the natural exposure program within this year. And also, we are collaborating with Lawrence Berkeley in order to examine and test the applicability of their accelerated aging protocol in European conditions. That's all from me. Thank you very much.